Welcome to section 7.4, adding and subtracting radical expressions. Alright, so first off, example 1, determine which of the following are like terms. Okay, so once again, you gotta be careful when you're looking at like terms. The radicals are important. Make sure that the same type of radical when you're trying to add or subtract, which means the values on the inside need to all be the same, exactly. And any variables in the front also need to be the same. Okay, so let's go ahead and take a look. Try to see if you can get these matched up. Pause the video and check it out by yourself. Alright, so let's see. We have 2x root 7. I'm going to search for any other x root 7s. Ooh, I found one. And that's it. So 2x root 7 and 4x root 7 are like terms. Next one, we have the square root of 7. Another square root of 7. So 3 square root of 7 are like terms, and square root of 7 are like terms. Next we have y cube root of 9. Ooh, look, there's a y cube root of 9. So 5y cube root of 9 and 2y cube root of 9. And lastly, we have the poor little left out guy, cube root of 5. So when I'm adding or subtracting, what do I focus on? When you're adding or subtracting, you always focus on the number in the front. So for example, 2 and 4, you would add or subtract those, and then just rewrite the radical at the end of whatever the answer was. So if I was adding, I would get 6x root 7. If I was subtracting, I would get the 2 minus that 4, so it would be negative 2x root 7, and so on. Just focus on the first numbers, and then you write down the like term. Alright, so let's take a look at example 2. Add or subtract to simplify the expression. Well, for part A, are these guys actually like terms? Well, they both have the radical 5, so they are. So I'll go ahead and add up the 3 and the 2, and we get 5, and then we write down their like term, root 5. Let's take a look at the next one. Are these guys like terms? Well, we have an x root 7y. Well, there's another x cube root 7y. Ooh, you might be tempted, but this one is different. There's no y under the radical with the 7, so that's not a like term. Which means the only way we can combine are the 2 and the negative 1. So that'll just be 1x cube root 7y plus the 8 cube root of 7. And we're done. Now the last one. Once again, always check to make sure they are the like terms. We have a y cube root 3. Ooh, another y cube root of 3. Oh, this one's sneaky. Sorry, those weren't the cube roots. That's a y square root of 3. This one's sneaky. The y is inside, but that means it's different. The other ones have the y outside the radical. This one has the y inside. So the first two are like terms. So we have 1y minus 2. So that would be negative y cube root of 3. And then this guy did not have any like terms. Alrighty, not too bad. Just got to be careful, make sure you're checking things right. Now let's take a look at example 3. Add or subtract the radical expressions. So the first one we have here for A. Well, you might be tempted to see if any of these are like terms, and right now none of them are like terms. But notice there are rather big values inside the radical, which means we might be able to simplify them. So let's take a look. When I'm working to simplify, I always like to create what I call the perfect cube. Those are the items that will be perfect. And then the imperfect. Let's go ahead and write out that's 16x cubed on the side. I want to try create this, or split this, into perfect cube values. Is 16 a perfect cube? It's not. 16 is 2 times 8. 8 is 2 times 4. And 4 is 2 times 2. Is there a perfect cube in there? Well, I can rewrite it as 2 cubed, because there are 3 2's, times 1 2. So when I rewrite this, that perfect cube is going to go inside here, And then the imperfect will be placed in the end here. And then we have that x cubed, which is a perfect cube, so we'll go ahead and write it in the perfect cube. So now, if this step is a little confusing, then we go ahead and rewrite the step that would be before it. The step before it would have been when they were all still under the same radical, and then I split them into their separate radicals. So it would have been 2 cubed times 2 times x cubed. I usually just skip this step, but if this step in between helps you, by all means. Okay, so we simplified that. Let's go ahead and simplify the other ones. 54. How can I simplify 54? Let's go ahead and factor it, because I'm not certain. 54, that is 2 times what? 27. If you're not certain, you can go ahead and do the long division. And then 27 is the same as 3 times 9. And 9 can still be factored into 3 times 3. So my question, do I see the same number appear 3 times? I do. 3 appears 3 times. So I can rewrite 54 as 3 to the third power times 2. Okay, so let's go ahead and do that. So that's going to be minus 5 cube root of 3 to the third power times 2 times x cubed. And we can rewrite that one into the perfect and imperfect cube roots. Alright, so let's go ahead, just fixing my radical. So that'll be 5, and the perfect cubes are the 3 cubed and the x cubed. And then the one that's imperfect would be the cube root of that 2. Alright, and lastly, I have a negative 2 inside there. Well, I can't really simplify too much, but I can still pull out that negative. So I'll factor out that negative because there's a cube root. So we have negative 4x cube root of 2. So notice here, if that had been the square root of negative 2, that would be not a real number. But since we have an odd index, which is a 3 in our case, we could pull that negative out. So keep an eye on that. Alright, let's go ahead and simplify. So the cube cancels with all of those, and I'm left with 2 times 2x cube root of 2 minus 5 times 3x minus 4x cube root of 2. Simplifying, I have the 2 times the 2, so that's 4x cube root of 2 minus, and the 5 times the 3, 15x cube root of 2 minus 4x cube root of 2. Okay, are these like terms, and can I simplify? What do you think? They are. There's an x cube root of 2, x cube root of 2, and x cube root of 2. They're all like terms, which means I'll go ahead and just add up the numbers in front. So we have a 4, a negative 15, and a negative 4. So 4 and the negative 15 would be negative 11 x cube root of 2. Still have that negative 4 to work with. Then we can add up the negative 4 and the negative 11. And what do we get? Negative 15 x cube root of 2, and we're done. Once again, be careful how you write your work, because notice this is starting to look like I'm writing x cubed square root of 2, which it's supposed to actually be x cube root of 2. So once you start getting all the exponents and radicals, you got to be careful with your handwriting. Even I get a little messy sometimes. Okay, ooh, one more to go. Ooh, but this one has a lot going on. So we have some fractions. I'm going to try to see if I can simplify the fractions. So let's go ahead and split them. That'll be the cube root of 16 over the cube root of x to the 12th, plus 7 cube root of 9 over cube root of x to the 9th. Can I simplify these? Well, if you recall, 16 is going to be the same as 2 cubed times 2 over and x to the 12th. How can I rewrite x to the 12th to be something cubed? Well, what times 3 gives me 12? 4, right? So if I rewrite it as x to the 4th raised to the 3rd power, it's the same thing as x to the 12th. So I'll go ahead and do that. Sneaky, sneaky. Okay. Let's take a look at the next one. Once again, what are we doing? We're trying to simplify the radicals. So we're trying to rewrite everything in terms of the index, which happens to be a 3 for this problem. Plus 7 and 9. We can't simplify 9 because that's just 3 squared. So 9 is stuck. And then we have, let's see, cube root of, we can rewrite that as x cubed cubed. Okay, so let's go ahead and simplify. Oops, that should have been written as 4 to the 3rd power. Typo. Okay, so that cancels to that, and that, and that, and that, and that. What am I left with? 6 times 2 root 2 over x to the 4th plus 7 cube root of 9 over x to the 3rd. And that will be, let's see, well, we still haven't actually added or subtracted these, so we need to create a common denominator. So I can actually rewrite this as, I can bring up that 6, because that's 6 times that all. That'll be 6 times the 2, which is going to be 12. And then this will be 7. I can just go ahead and rewrite the 7 up on top. So now I need to add or subtract these fractions, and since I just need to add it, I need to create a common denominator. Well, I have x to the 4th and x cubed. I can create x to the 4th on both of them by multiplying this one by x, and then I'll get to 12 root 2 plus 7 cube root of 9. Oops, that should be cube root 2. Careful. Sometimes you can drop the radicals just like I did right there. And then divided by x to the 4th power. And that is basically all we can do. So we're done. We've added them. We can't simplify the top because there are no like terms to add or subtract in the top, so we're done. Alright, if you have any questions or need any help with this, once again, please stop by my office hour.